accessories required for VNA are two coaxial cable depending on the number of ports. Normally we are having the 2-port VNA and a calibration kit. Calibration kit may have the component like separate component of the open short through and the mesh rod, whereas this company has supplied you can say single structure for making all calibration components. Okay. So and again for the selection of this I have taken one extra calibration kit of the type N. So this is type N female calibration kit. And this side just for your own understanding. So both sides having the type N male connectors. I can connect this calibration kit with this connector for the calibration, or if I want to use the SMA connector for SMA calibration kit, I have to have connect a adapter. Adapter is converting from type N to SMEs, right? So I have selected a component, this one, which is made on the SMA. So I can use SMA calibration kit to calibrate the V, right? So I'm leaving it ready, and you can see some knobs which are placed on the display or the front panel of this kit. And every keys are having separate functions as per the name is suggested. If simply we can see the press cal. When you are pressing the cal, what are the options coming?
Center span, full to port, high, twist.
Okay, so this is full 2-port and this is full 2-port. यहाँ के नीचे क्या लिखा है? High accuracy. This is full 1-port. And this is other cal
settings, cal kit.
Or this is about the cal kit. Okay. The full 2-port calibration and another is having the full 2-port high accuracy. So we will not jump to the high accuracy calibration. Let's see what are the steps involved in the full 1-port calibration, which is easier. First we will see, then we will perform the calibration. So if I press the full 1-port, it is asking you. What is asking? Okay, it is asking you select the calibration kit. Okay, now every VNA model is supplied with some specific calibration kit. Like this is having the calibration kit. Here like a JB
217
okay.
Z17.
Okay, so we must select this model from here. And if I back option है कि ये क्या लेगा? Cancel. Okay, cancel. If I go for this is asking me क्या लिखा हुआ है?
For a calibration kit is selected for this calibration. FSH Z28. Press continue to start the calibration. Please connect a port.
So this is giving you the option. Calibration kits. Details of the calibration kit are installed in the memory of this VNA. You can able to select the proper VNA calibration kit which is supplied to you. You must see there is a model JVH
170 female kit. Second last.
This one, na?
Yes. Select.
So now this VNA model is selected. Now when you go for this is coming. You have to use the VNA model which is selected by user. Okay, so this model is supplied to you. You have selected the model. You can use any other calibration kit also which are installed here, but right now we are having only this particular model of the calibration kit. So this is selected. Now continue. So it is asking to connect
open to port 1.
Open to port 1, right? So we will connect this is port 1. Where is the open? Okay, we are just switching this VNA in the sense that we have given it option to calibration kit of this one, but right now we want to use on our own calibration kit, which is different than the calibration kit it is installed in this VNA, right? So we are ditching.
इसको थोड़ा और इधर कर दिया, अदरवाइज आपका ज़्यादा आएगा.
So open is ready to what is asking for?
Continue.
No, continue. Regular person F2. Now what
Please
is-
select short to quote one.
Okay, so similar kind of a thing we have seen in the SNA. Similar kind of thing. This side is a short.
Please correct
Load.
load to quote one.
So I'm using this load, although this is a low frequency load. Okay, we have verified with the SNA measurement, these are the low frequency load, but we don't have any of the other option. Percent for SMA, so I'm going to do this. So, now what is that?
Calibration done.
4 gigahertz. Span 98.
The response is changing, and the value of this response is now from about 20 dB. Okay, let's say from here 20 dB to is reducing to 40 dB. At the last frequency, it is giving the 40 dB. So you can obtain the value of return loss. This is showing the value of return loss, starting from about minus 20 dB at low frequency to the minus 40 dB. So which is that means it is absorbing all of the microwave signal, and the return power is very small. And also you can see this is representing trace S11 magnitude only. Okay, trace S11 magnitude only.
सर ट्रेस का मतलब क्या होता है?
S1 को ट्रेस करना है.
Okay, trace mode. Okay, trace mode. We can remove or we can add the separation on and off. Yes. Right now it's not giving me the option. Okay. Now, which parameter I can measure or would like to measure is the S11 right now, and S11 is here. And let me check any other arbitrary number, any other device. So after the calibration, I need to connect to the DUT. I verified the data that the value of return loss for the matched load is from 20 dB to 40 dB, which is a suitable range for the matched load. So now I am using a DUT, an unknown value, unknown load. Although I know this is a matched load, but let's assume this is an unknown load. And now the display will show you the value of whatever the display we can see, the reference level is 0.0 dB. 0.0 dB. Okay, so normally the short is having the 0.0 dB. That is the reference level. It is selected for return loss measurement of the DUT. Attenuation right now this is selected by 10 dB. So any power which is separated is again reduced by 10. Just only to show this is the bandwidth. Okay.
10 gigahertz.
This is the bandwidth. Okay, if you recall the plot diagram of the VNA, which I made in the last class in the plot diagram of the VNA. So in the plot diagram of VNA, I was using the two mixers in one channel. Okay, so this bandwidth is representing the bandwidth of the IF frequency. Second one, first one is the IF one, second one is the IF second mixer bandwidth. And this is representing the points, 201 points. From here to here, minimum frequency is how much? Can I see the frequency?
4.005 gigahertz.
Center frequency. The minimum frequency is having 9 kilohertz. See? I can change the number of points. Okay. So in the entire frequency range, I can select that total frequency range can be divided into 101 point, 201 point, or 401 point, and so on. The maximum range which this particular VNA is having is 1201 point. So let's suppose from the 10 megahertz to 8 gigahertz. This frequency point can be divided into 1201 point. Total number of points on which I can able to divide the entire frequency range is 1201 as per this feature. Right now it is by default it is selecting the 201 point. Okay. Trigger pulse I can also provide us, but normally we do not use trigger pulse. That is for specific measurement.
PG power means
Trigger power. Okay. This particular VNA, this particular model of VNA comes the two kind of mode. One is the network analyzer mode, and the second one is cable and antenna. Okay, so we will discuss about the cable and antenna later on. And one more thing. Right now it is measuring the S11. I can set some marker. Okay, so marker value is this. So this marker value, the frequency is 1 megahertz, and here the value of this is how much?
2.
So value of return loss is changing. I can shoot the marker value also, just like cursor. Okay. And also it is providing some other position. You delete, you can select. And now it is showing me the option of representation of the complex number or the scalar number. Now change the value. So VN is now giving you the complete range. And again, VN manual place. So this is 81. Here the value is shown in terms of
6 gigahertz.
I don't know about this particular MP.
80.228.
Must be some in terms of magnitude. And this again this angle. And one more mode we can see. The element image.
50,
So this is
56. 56.
Same. This is the same number, but because the mark is placed in the same position. This is 56, the real part of the reflection coefficient. This is the unity part of the reflection coefficient. Another 6.
So reflection coefficient should be less than 1.
वो ये impedance है ना बच्चा?
Impedance हो गई.
It is directly giving you the value of impedance. देखा ना R plus Jx. This is the real image. This is the option.
0.06.
Okay, so by with the help of VNA, we can directly measure number of parameters only by pressing some keys. Now I am going to perform the two-port calibration. Okay, press the cal. two-port. ठीक है, अब कैल्शियम फिट जो भी हो. और हमने तो वो तो किया ही नहीं. ये तो किया नहीं वाला मेजरमेंट. इसने बताया भी नहीं आपको.
तो ये भी नहीं थी.
तो सर आपने कंटिन्यू है प्रेस
कंटिन्यू है ना. एक का नाम लेता है. हाँ कोई बात नहीं, ठीक है, कंटिन्यू करो. अब क्या बोल रहे हैं?
ओपन टू पोर्ट 1.
Let's go.
Open to port 2.
So it is for the two-port calibration, VN is asking to connect the same standard for
Port 1 and port 2.
okay, for both the ports. Time is on.
डेट में से
Video set है ना इसमें? मतलब ये कि आपसे ना ऐसे मतलब चीटिंग नहीं कर सकते साथ. इसे हमने कल रीडिंग ले ली थी, हमें परसों रीडिंग ले ली थी. Open is connected to second port. हाँ.
बैटरी पे होता होगा तो ये
शॉर्ट पोर्ट पर
तो वही हो गया. Bye. Getting the score. Short to open.
short to port. Blue to port.
So while I am connecting the all standard to the respective port, it is storing the data of the measured calibration standard in this memory, and it is performing the same equation, calculation of error terms on both sides for the two port. Now load to port 1, right?
Yes. Load to port 2.
Through connection.
Replace the DUT by through connection. Replace the DUT by a through connection.
So I am having a female to female through connection, and to connect these two ports, this is a through connection.
Calibration map.
So we have witnessed the calibration of the two-port network. So for the two-port calibration, we have connected all the one-port standard in both ports and the through connection between the two ports. Now we can place any DUT. Go to the message, press the message. What is showing? Okay, so this is showing us right now S11, press S21, F2. Okay, through connection means there is a no loss. Through connection means there is a no loss. So the value of system loss must be 0. And you can see this value in the marker.
Loss is 10 minus.
Okay, you can see this value in the marker. What is the value it is showing on the trace? Trace means the data which is showing on the graph. Okay, so this is a trace of S21 of calibration data and magnitude only, right? And from here, marker, and normal TV.
Down. And down.
So at this location, or the marker is representing the value of resistance loss and the phase. So all US side. Okay, you can see there is a change in the value of phase, transmission phase. So with the VNA, you can directly measure the dp value of the insertion loss and the associated phase at any particular frequency range or frequency point. So this sorry क्या बात है तो बच गई important है. Okay. So now I am going to connect a DUT. I do not know the properties of the DUT. Okay, one more important thing. If you see the SMA connectors, this is also SMA connector, this is also SMA connector. Here the polish of the gold is no, it's finished or you can say reduced, but here is the finishing is perfectly. So gold is having very high value of conductivity. High value of conductivity means amount of conductor loss is less. Amount of conductor loss is less, that means this will provide us less insertion loss. Especially when in case of the high frequency operation, we want a conductor which will have very high value of conductivity. So the conductor loss will be almost net or zero. So now here you can see the value of insertion loss is very high, about 40 dB range, and then the value of insertion loss is reducing, and then it is further reducing on this side. So here the value of insertion loss is minimum. So we can say this particular frequency is having this particular value of frequency. Which frequency?
4.8.
4.8.
4.84.
Also shift to the little bit cursor. Okay, so this is the minimum value of insertion loss minus 5. So this particular frequency is passing from one port to the another port by a value minus 5. At other frequency point, we are having high value of insertion loss. Now press another key. There's some measure. Okay. So what we are measuring? We are measuring the S1. Okay. Press S1. 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 Okay. So the value of return loss can be measured. This is the value of return loss S1 in dB as well as in the value of phase complex number. Okay, press S1 to F3. So if I compare the response of S12 and response of S21, okay, this is response of S12 and this is response of S12. 2. Okay, 1, 2 and 2, 1. Both response are same. If the response of S12 and S21 is same, that means this is a reciprocal component. So we can know on the basis of scattering parameter data whether the component is reciprocal or non-reciprocal. Okay. So theoretically we have studied if the scattering parameter S12 is equal to S21, that component is reciprocal. And if we similarly replace the S22, okay, now if I compare the data, S22 is this particular code, and S11 is this particular code. Both the response are a little bit changed. That means this component is having S11 different than the value of S22. So we can able to categorize any component, two-port component, for all scattering parameters, and based on the values of a scattering parameter, we can able to understand at which particular frequency is being passed, or how much frequency is going to stop, or which particular frequency we can use this particular component for our application. Obviously, we want the minimum insertion loss, maximum value of the maximum power should be transmitted, not reflected, depending on the type of applications. So we can get many information on the basis of this complex measurement of the scattering parameter using VM, right? And we have seen in the previous measurement also that this measurement we can measure. We can have the form of dB phase, we can have the form of the linear phase, we can have the form of the real and imaginary, and also we can obtain the respective impedance. Impedance at port number 1, impedance at port number 1. Let's see this thing. So there is a marker and marker mode, and it will show me some reading of real imaginary. Select, and just right now measuring S11. The value is 0.48 minus J 0.11, right? And then I can select S21. This was selected in the DPO value. I have to change selection with the help of marker to real imagery. So this is giving only the dBm phase. Okay, by the conclusion also we can able to convert to the linear phase or the linear value. And if I like to measure S12, this was the marker. Same. So this VNA is having the features of representing the deviant phase, not the linear phase of variability for the transmission coefficient. But other VNA may have the same features like for the S11 or the S22 parameters. Okay. Now I am going to connect a 3-port component. I am having the 2-port VNA, but I am going to characterize the 3-port component. 3-port component will have total scattering parameter 9 scattering parameter. Okay. So depending on my own selection, I can place the number of ports 1, 2, 3, 1, 2, 3, or 1, 2, 3. For the measurement, you have to select, you have to specify which port is you are designating as a 1, 2, and 3. So let's, I am taking this as arrangement. This is 1, 2, and 3. दक्षिण निकाल रहे हैं क्या हम लोग आई कब okay, so this is port number 1. I'm designating as a port number 1, 2, and 3. This port should not be open. This port should be terminated with some 15.
मैच
शॉर्ट से करोगे, शॉर्ट से तो हम गेम करेंगे, शॉर्ट करने की क्या होगा बच्चा सोचेगा, ठीक है।
यहाँ शॉट लगा दिया तो क्या होगा?
सोचो क्या होगा, मेरा पहले रखिए।
सर पेन
अरे मेरा पेन किधर है? ठीक है, लड़की सॉल्व करती है कि शॉर्ट लगाने में क्या होगा। ओके, सो दिस इज अ कीबोर्ड कंपोनेंट, इसको ओपन कर रखा, बाय आपके दिस ओपन,
देखने के लिए
why this is open? ये तो मेरी मेहनत का असर होता है। ये बोलते हैं कि नंबर कम देते हो, अभिषेक करता है ना।
सर रिकॉर्ड हो रहा है।
ओके, सो यू कैन सी, ये ओपन ना इसलिए रखा था कि यू कैन सी, नाउ यू कैन सी। मैं क्या करूँ, मेरे शॉर्ट शार्प है तो ओके, सो इट भी बंद कर दे बच्चा।
अरे बहुत नहीं हुआ है
बाबू सुना नहीं है। सीधा पकड़े हुए कभी सारा रहता है। हमारी पहले में कुछ ना बोले क्या होता है, इलेक्ट्रिक क्रॉस हो जाता है। बड़े गलती से तुमने दिखा दिया ना, मंदिर तुम्हारा ना बन जाएगा। तो बोले ऐसी जगह पढ़ते हो, पढ़ते क्या करने जाते, ठीक है। इवनिंग में कुछ बोलते सब अच्छे हंसते हैं ना, तुम मुझे बोलो तो मुझे भी सुनाई देना चाहिए। क्या फिर अंडरस्टैंड यू आर ओनली स्माइलिंग। मैं तो गलत समझ लूँगा, तुम मेरा मजाक बना रहे हो। बोलना मेरा बोलना था ना उसको। So input signal is coming on this direction, and as per whatever this component, I have entered the put on this. So any power which is applied on this particular port will go to this, irrespective of the amount of the power, depending on the structure of the component. And when the signal will go, if any power which is reflected back will go to this port or this port. In that session, this is a circulator. In that case, the power will go on this direction. And if I place a short, that will act as a incident signal to this from here to here due to the high reflection. If I place a match load, none of the power will be reflected back from this number port to port number back. So this port will remain as straight. This is the only change. अब बताओ कितना आ रहा है? S1 कितना आ रहा है?
-5.09.
Is this minimum value of S1?
मिनिमम तो यहाँ पे आ रही है, मिनिमम उस पर आई।
मौका मिला तो बस मौका खराब कर दिया ना।
सर मार्कर ऑन ही नहीं है। अच्छा मार्कर ऑन नहीं है,
खराब कर देता कोई विषय
हाँ खराब कर दिया ऐसे।
-15.5 15.557.
So you can see this is -15. This is which
यहाँ
parameter?
पे इम्पिडेंस कैसे देख रहे थे?
This is S11.
यहाँ पे फिर हम इम्पिडेंस कैसे देख रहे थे?
प्रेस करो F5।
हाँ समझ गए।
बस वापस आ जाओ, ज़्यादा कुछ नहीं जरूरत नहीं। And then measure S21, S12 sorry, ये सेम कंपोनेंट है ना जो पहले दो बोर्ड का बनाते हैं ये,
सेम ही है।
ठीक है। देखो कैसे नंबर शार्प हो रही है। Okay, reciprocal component. S12 and S21 is same.
Same.
And S22.
Almost same.
That was
नहीं सेम नहीं है.
So by connecting the VNA ports to the ports of a device, I can able to measure 4 scattering parameters. A single casing of it. Okay. These data can be stored in external USB drive, or I can able to connect this VNA to the external computer or laptop to store the data. वो डेमो मैं नहीं करूँगा, बहुत टाइम लगेगा. क्या विषय? अरे तो समझ में आ रहा नहीं आ रहा है? क्या है? बोलो सर, ये जो आपने सारी VNA बेंच लगा रखी क्यों लगा रखी है? सबको ये VNA क्यों पढ़ाते हैं बेंच वाइज? ऐसा कुछ ख्याल तो नहीं आपके दिमाग में? अरे कर लो ना, ख्याल तो करते नहीं है. मैं फर्स्ट में सब बच्चों को ना ऐसी लास्ट टाइम में कहा था. उसको देखो, मुझे क्यों देख रहे हो? मैंने कहा था ओके. नाउ आई एम एबल टू सी द 4. अभी किसमें कौन सा क्लिक?
S11
चलो बताओ क्या?
S22
F2. Okay. So it is giving the same response. ठीक है, same response है ना? अभी earlier this two are connected, now these two are connected, and this is giving us almost the same
Almost
response.
same.
So the transmission or the reflection between these two ports are same. Either you can select any of the two ports. So this is again a reciprocal network. ठीक है, अब किसी को सॉल्व करना तो पूछो. हम लास्ट में क्या जोड़ा
हो गया.
-17.4 मिनिमम है.
फ्रीक्वेंसी मिनिमम पे ही है.
हाँ मिनिमम पे 2.0. सेंटर फ्रीक्वेंसी सेंटर 4 है. मिनिमम ये है.
वो ज़्यादा नीचे लग रही है. ये तो सेकंड लाइन.
इसमें ना मिनिमम के क्वेश्चन होते हैं, मुझे दिख नहीं रहा.
उस पे चेंज हो गया.
चेंज हो रहा है. चेंज हो रही है. अपने हाथ रख.
तो जबरदस्ती से ले सकता तो कुछ नहीं है ना?
हाँ 4.9 4.96.
196. What is the value of return loss?
-15.19.
ठीक है, there is a marker. ठीक है, marker select.
सेलेक्ट मार्क करके
And select that R plus JX.
वो मार्कर मोड पे ही है. R प्लस JX मार्कर मोड पे R प्लस JX
40.5.
Okay, so this is the 40.5. So we can also able to obtain the value of casting impedance. This is not the casting impedance. This is actually the input impedance of the mesh simulation. Sorry,
पता कैसा महक रहा
mesh
है.
patch.
होम्योपैथिक दवा की.
So this is one port measurement. We can measure here, measure lower. We can measure here. Scattering parameter S11, magnitude phase, or directly impedance. So this all calculation, simple जो calculation करते हैं ना, impedance inform if we are having the value of reflection coefficient, how we can calculate the value of impedance. That is the same algebraic equation is compared in this one. If I go for this particular, this is the maximum matching is occurring at this particular point.
Two point zero zero.
The value is again 40 points.
40.1.
ये बिल्कुल एक्टिव पे नहीं आ पा रहा है. ये तो होना चाहिए.
ये तो इम्पिडेंस रिफ्लेक्शन कोएफिशिएंट.
So this antenna is also working fine at some frequency point. And again, similar to the same way, we can also able to obtain. So if this is the central frequency, we can go for another frequency point where the value of S11 is some other value of impedance, or in terms of say dB. So we can select the true value of frequency where the value is about 10 dB. Okay, so 10 dB is rated on this side, 10 dB is rated on this side. So based on this, we can able to obtain the impedance bandwidth. That maximum or the minimum return loss is some at the resonant frequency. There are the two frequency point where the value of return loss is about 10 dB. So that will form the bandwidth, and from using the bandwidth and the resonant frequency, we can able to obtain the Q, quality factor of this particular patch antenna at some certain frequency. So this is one peak, this is another peak, and this is another peak, this is another peak. This also represents that this antenna is resonating. This antenna can able to radiate some other frequency other than the first dominant frequency. So normally the minimum frequency which it can able to radiate will come early, and then it is having the multiple of those frequency or some frequency point. So it is possible to categorize single frequency antenna to the multiple on the broad frequency range. If the same antenna is radiating at other frequency, then the design value it can able to show the negative peak in the return loss performance. Based on that, we can able to check the same antenna can able to radiate one frequency, two frequency, three frequency, or number of peaks, number of negative peaks. चलो हो गया साफ और साफ होने की उम्मीद है?
नहीं.
तुमने बहुत जल्दी हार मान ली.
नहीं, हार नहीं माना, सब इसको बहुत देर से किया.
हाँ तो मैं भी ट्राई करूँ क्या?
कर दे.
मुझसे कम